Good morning, everybody. Today we are going to be finding the area of triangles using a couple new methods. These methods are used when we're not working with right triangles or if we don't know the height of a right triangle. Just a heads up, the first two problems on the note sheet, if you are someone that's looking at those are both looking at proofs and then finding the area of these using those proofs. I'm going to skip those just to save you the time. It is in the textbook if you have it. If not, I am attaching those pages to the assignment. So take a look at those proofs if you'd like. But they're coming from there. And those two proofs give you the area formula, which we have. This is in general when we don't know the height of a triangle, and we need to find that height, or if it's a right triangle, or if it's not a right triangle. So those formulas are all here. Basically, it's the same exact thing, just using different scenarios. If we draw a triangle, we can see that what's going on here. So we'll say C, A, B, C. This would be alpha. This angle. This would be beta, and this is key. And if you're looking at these, the area is going to be 1/2 times A times B times sine of this angle. So it's a side angle side relationship that you're able to use this with. You do need to know those three pieces in any one of these orientations. So A times C times sine beta, B times C times sine alpha, all of those times 1/2. And what that's doing, sine of this gives you the height. I know I said I wasn't going to go over the proof, but this is a short version. It gives you the height of this. So sine of this times B gives you the height. So then you can do A times height times 1/2, and then you get the area of a triangle. So that always works. It just depends on which height you're looking for, where the opposite to that side, or one of the adjacent sides, is the base. One of them gives you basically the hypotenuse of this right triangle that you made. That's the shorthand version. Another way of finding an area, if you don't know any of the angles, you just know the three sides, is using Heron's formula. And this proof's a little bit more complicated. Again, I will be including it on the assignment, so if you want to look at it, feel free, or you can Google it if you don't like this version of it. But it's a cool concept. You need to find the semi-perimeter, which is S. So S is found by 1/2 of the perimeter. So you need to find the perimeter, add up the three sides, multiply by 1/2, and this is your S value. Then you're going to take S and plug it in, and then so you see S in here 4 times, and it'll be S times S minus each of the sides separately. Once you take the square root of that, you have the area of a triangle. Pretty cool that you can do this. In some ways, it's simpler than doing base times height divided by 2 because you don't need to know the height. You just need to know the three side lengths. But if you know the height, then obviously this isn't easier. Just creates a different set of things you plug in. All right, so let's use these. In number 3, again, 1 and 2 are going over proofs, but in number 3, we have a side angle side relationship. So we're going to be using that first set of formulas that we have, which is 1/2 AB sine, and we are going with a key because it's opposite to C. So the area is going to be this. And you don't need parentheses. I don't know why I put them there, but plug everything in, you're good to go. So the area is equal to 1/2 times 6 times 8 times sine of 30. Remember, side angle side. If we knew this angle, we wouldn't be able to use this, so just make sure you're plugging in the correct values. But 1/2 times 6 is 3 times 8 times sine of 30 is 1/2. So this is 3 times 4, or 12. And we'll say square units. but just like that. And again, this is basically 1/2 base times height. Just your height is given by that one. Find the area of this. This time we have 3 sides. So the 3 sides, we don't have any angles. We have to use Heron's formula for this. And Heron's formula is S times S minus A times S minus B times S minus C. And S is half of the perimeter. The perimeter is equal to 4 plus 5 plus 7, which is 16. S is equal to 16 divided by 2, or 8. So I'm going to take 8 and plug it into all of these S's. So 8 minus A is 4. It doesn't actually matter what you call A, B, and C. It should all work out in the end. Okay. From here it's just simplifying. So 8 minus 4 is 4, 3, and 1. Square root of that. This is 96, so square root of 96. And if you simplify this number, it should be 4 root 6. 16 times 6 is 96. Yeah. So 4 root 6 in square units. It's a pretty nifty trick if you don't know any of the angles and you don't know if it's a right triangle or not. This does work for right triangles too, so you don't have to check to see if it's right triangle or not. If you recognize it's a right triangle, feel free to use base times height divided by 2. It's just some people don't want to have to think before they start working. Alright, same issue here. We need to find how much it costs to plant enough seed or buy enough seed to properly seed a field that happens to be triangular. Go figure. But quick diagram of what's going on here. It's 250 by 175 by 125. You could check to see if it's a right triangle. I doubt that it is. The only other information is based off of how much a bag of seed covers. And we're going to assume that you can't buy partial bags. So at the very last step, we're going to have to we are going to have to round it up to the nearest whole number so we can make sure to have enough seed. Alright, well, no angles known. You could either try to find an angle or you can use Heron's formula. I suggest Heron's formula. With that, you're going to find S, which is 1/2 of the perimeter. Ooh. Also, if you hear kids laughing, those are my neighbors playing with their brand new electric car. So, sorry if that's bugging you. Or sorry if your teacher's getting bugged by it or distracted by it, I should say. And you're not. Alright, so S is 275. I plugged that in my calculator before, so don't worry. I'm not that proficient with my multiplication of fractions. But 275 should be S, and you are going to plug that into Heron's formula. So area is equal to the square root of S times S minus A times S minus B times S minus C. All of that should be 275 times 25 times 100 times 100's over here times 150. Okay, and type that in your calculator. You should get that. It's about 10,155. That's square feet. 10,155. Now, a bag of seed should be covering 500 square feet. So we just need to divide this by 500. Which should get you, again, about 20.3. So 20 bags would get you almost the whole way. We can't buy part of bag. We would have to buy 21 bags of seed. And 21 times the cost per bag will tell us the final price, which should be $271.95. Okay. Overall, not too bad. Just learning 2 new formulas and practicing with them. But that should be it for today. So hope you enjoyed it, and I'll see you next time.